Okay, so I did put some more notation here. Well, here, move that. All right. Okay. Generally, what people do to denote a function is they use letters like F, G, and H. They use F, G, and H to denote functions. Again, from the context, it will be clear what letter denotes the function, but generally it's going to be F or D. That I see that a lot. And what they do also is they'll denote the function. They'll write something like this: y equals f of x. They'll write this. And now what is this really telling us? This is really saying that the function name, which is f, takes the input, which is x, and it gives you back the output, which is y. So this is saying that x is our independent variable, our input, f is the function, y is the variable that represents our output. I don't know if anyone here has had Math 104 with me, but they have these correspondence diagrams also that help. So I probably should have drawn those, but I guess it's okay here. I mean, I'm approaching this differently than I would in Math 104. I'm approaching it the way the book does. We also have this diagram here. You know, again, x is going into the function, which is f, okay? The green circle you could think of as representing f. You know, you can't see what it's doing to x. It does some crazy stuff, but it gives you back f of x, f of x. And again, for each input, you only get one output. For each input, you only get one output. That really is the crucial part, okay? Each input, you get only one output. I mean, it's not going to help us if the function gives us two outputs back, because we won't know which one to use. You know, do we use this one or that one? Now, let me just say this also. The domain, that's the collection of all inputs, okay? The domain, that's the collection of all possible inputs, okay? And the range, that's the collection of all outputs. The domain is the collection of all the inputs. The range is the collection of all the outputs, okay? That's what's happening. And actually, instead of the word collection, they use the word set, S-E-T, but here I'm just using collection, same idea. All right, so that's fun. Let's do an example. So let's say f is a function. What it does, it takes in the number of, it tells us the number of days in a month. So in other words, the function takes in month as your input, and it gives you back the number of days in that month. So the function, again, it takes in as its input the month, you know, January, February, August, whatever, and it'll give you back how many days are in that month. So going back to our notation, X would be the month. So X could be January, X could be February, it could be May, and so on. And then Y, which is f of X, Y is the variable that holds the number of days. In other words, Y is the variable that holds our output. You know, the output's got to be held somewhere. That's what the variable's used for. X is the variable holding the month. It's January, February, or whatever. You know, mathematicians like to use notation. I know notation can be cumbersome sometimes, but not always. But it is useful, though. Y holds how many days we have in the month, that is. And then this would be, and our function then would be given, our function then tells us how many days are in each month. And here I made a table to list some of the function values. So if X was January, then the function, if you plug that in, the function would give us back 31. You know, there's 31 days in January. If September was our input, the corresponding output would be 30. If August was our input, the function would give us back 31. I didn't put it here, but if we put November into the function as our input, the output would be 30, and so on. So that's one example of a function. And it may not be what you expected, because you probably expected x to be numbers as well, but that's okay. Are there any questions on this? Okay. All right. Now, there's actually different ways of representing a function. I think the question that someone asked before about an equation, that's going to be tied into this. You could always write out in words what the function does. That's one way to represent it. Oh, sorry. That's actually kind of what we're doing here, right? F is the function, tells us how many days there are in a month. You know, that's one way of representing a function. You could also use a table if you want. So I kind of do that here as well. Although this is not all the possible input, it's only part of that table, so to say. But you could use a table to tell us what the function does, excuse me. You could use a graph. Namely, you can work in the Cartesian plane, or the XY plane, in other words. Right? In high school algebra, I know, they have you graphing polynomials and sketching graphs and stuff. You are graphing in the Cartesian plane, the X and Y axis. And of course, you can use a formula. Basically there, f of the function would tell you how to calculate the output from your input. You know, of course, algebra would be used there. So there are different ways of representing a function. Now you might be thinking, well, why not just always use a graph or always use a formula? Well, you can't always do that. You may not know enough about the function. So you may have to use a table, or you may have to write out in words what the function does. You know, that can happen. That's why it's useful to have more than one method for representing a function. Okay. And here's just some more terminology before we do more examples. If we do have input and we want to get the output, we are evaluating a function. So if, in other words, if we know what our input is, our x, we want to get our output, our y value, we're evaluating a function. If we're going the other way, though, that is, if we have the output and we want to get the corresponding input that the inputs that produce the output. So if we have an output and we want to know what input values will give us that output when plugged into the function, then we're solving an equation involving a function. So if you went back to that month example, let me go back to this one. If I gave you January and you got 31, you're evaluating a function. You know, I give you the input, you get the output. But if we go the other way, so if I give you 30 and I say, find the inputs that give me 30, or in this context, what months have 30 days in it, what months you plug into the function to get 30, we're evaluating a function. No, excuse me, we're solving an equation involving a function. So if I gave you 30 and I asked you what months give us 30 in the function, we're solving an equation involving a function. That's terminology. You know, math does have vocabulary that's good to know, you know, like any other science. All right. Here's another example. Let's suppose g, so now the function is denoted by g. Let's suppose it's a function and we're defining it by this table. So this table is telling you what the function does. Okay? Let's say we wanted to know what g of 3 is. Well, what is g of 3? Well, how do we get that? Well, here for g of 3, I'm telling you that x is 3, right? So we go to 3 for x. Then we get the y value, which is 9. We get x is 3. Okay, x is 3. Here we're getting g of 3, which is the y value. This row, we get g of 3 is 9. When x is 3, y, which is g of 3, is 9.